So this is oxygen. So we're going to talk about water.
Really nice.
Water. And what's the most... please. What's the most electronegative element on the periodic table?
Fluorine.
Yes. What's the second most electronegative element?
Oxygen.
Excellent. That's correct. So, keeping that in mind when we're talking about water,
Yeah, he did.
what happens then with water is I get a charged molecule, right?
Right.
Let me go over it this way a little bit. Oh, right now. Okay. So here's a couple of pictures of water. So there's this one that represents all the electrons on it. So all of oxygen's electrons are represented here, and so are hydrogens. And so I have lots of negative charges on one side of this. And so if you remember from chemistry maybe, that we would call the more electronegative end delta minus, and the less electronegative end delta positive. And so because oxygen's the second most electronegative element, makes water a very polar molecule. Okay, so it also is responsible for some properties. Water is cohesive. What does that mean?
Bond itself.
Cohesive, yeah. So it sticks to itself, and it does that because it's got hydrogen bonds in there. So we're not talking about intramolecular bonds, we're talking about intermolecular bonds, right? So that hydrogen bond is between adjacent water atoms. And then some of the behavior of water is and how it behaves in living organisms is that hydrogen bond becomes very important physiologically. And so the electronegative end of one water sort of lines up or is attracted to the less electronegative end of an adjacent water. And that's what makes water cohesive. So you're going to do a lab next week, and you're going to observe some properties of water, and you're going to have to decide what property is responsible for each of the phenomena you're looking at. Is it cohesion? Is it adhesion? What property is it that is responsible?
That lab we did last time.
Okay.
Hey, we caught some of them.
Yep, water striders.
I hate them.
Okay, so because it's cohesive and it sticks to itself, that causes a property of surface tension. So normally a critter would sink when put in water. But because that water's so cohesive and sticking to itself, it produces surface tension. The water is so cohesive and sticking to itself so much that that insect doesn't have enough force to break through those attractions. So when water freezes, the molecules align and it creates these repeating hexagons. And that makes a big, giant structure. And the result is that solid water is less dense than liquid water.
Crazy.
You'll notice there's a 105-degree bond angle between the oxygen and the hydrogens. And its maximum density is at 4 degrees Celsius.
What is that in
Fahrenheit? 30, somewhere in there, close. And at 4 Celsius, what is that density, you suppose? Remember the SI system? 1 gram per centimeter cubed at 4 Celsius. And it turns out that, that's at liquid at 4 degrees Celsius, so slightly above freezing. And then as a solid, its density is 0.9 grams per centimeter cubed. So there's nothing else on that periodic table that displays that property when it's put together. And then as it freezes, kind of what Sundance was talking about, it expands, and it expands slowly. So we get really beautiful crystals that form.
You know when they say no two snowflakes are the same? I don't believe it.
That's what they say.
I don't believe it.
I don't know.
You know how many snowflakes there is? It smells like a bajillion
Yeah,
every year.
yeah. That's a
Bajillions
lot
are
of
like
snowflakes.
way,
Yeah, like
even a
snowflakes are tiny.
handful is like a million.
Now they
So it forms these hexagonal structures.
Hexagonal?
Hexagonal, a hexagon,
Hello.
which is what makes those snowflakes.
sell out.
And water is adhesive. What's adhesive mean?
Sticks to other things.
Right, sticks to other unlike molecules. And what that does is results in capillary action. And a great example of capillary action is how water's transported within trees. So the xylem in trees are the vascular tissues that transport water and minerals up the tree, and that's a long way to go. It really is it would require a lot more energy if water weren't adhesive, if it were possible at all to get that
How
water
does
to
water
the,
get all the way to the top of the tree?
because it's adhesive. So in these xylem
Is that like
structures,
when it maybe dried up a little bit before it got all the way up there?
Why does water move up a tree?
because
The
because they
roots are on the
still
ground, see, the
okay.
water
So why not? Tell me why
goes
not.
in the root and it goes.
Well, I'm just like saying, like I'm just really confused. I must be because
Where else would it?
like when
Shh.
it rains, it's it rains down it. But why would water travel up it? Just
So when it rains, where does the water go?
Down.
on the ground.
Yeah, so it goes to the roots.
And then it picks it up and water.
So it goes to the roots, and then it has to transport it to the rest of the plant. Does that make sense?
Yeah.
Okay, and then what are the reactants in photosynthesis? Maybe this is where there's confusion.
Sun.
Water, oxygen, and light.
No,
Yeah.
like,
So those are the reactants. So maybe that's what you're thinking is photosynthesis occurs in the leaves, and so the water, maybe you're thinking that's why it should be there first, but it's not. So that water is required
Sucked up those.
in the first phase of photosynthesis. And yeah, so it has to get to the leaves in order to undergo that photosynthesis reaction. So it has to travel up that way. So this is a really nice elaborate system to get that water up there. And so these xylem tubes are really narrow.
there's like 4 different kinds, or what's going on?
They are 4 different kinds. So it depends on the sort of evolutionary stage of that individual species. So some more highly evolved xylem tissues look more like that, flat,
Yeah.
with less of these sieve plates, they call them.
So like,
So more modern plants. Yeah.
What's a modern plant? What's an old school?
Okay,
Yeah,
so
old school.
old school plants are like liverworts and club mosses, and ferns are really primitive, and highly evolved plants are orchids. So they're the classic example of a highly evolved plant, orchids, and they're so specialized that they have co-evolved with specific pollinators. So if the pollinator species dies, then the orchid will die. So that water sticks to, because it's adhesive, it sticks to the sides of those xylem tubes and is pulled up by the tree. So that's adhesion. And water's a great solvent. So what does that mean? That means because oxygen's so electronegative, if I put something like salt in that water, like this little goofy drawing,
Water would dissolve
so,
it.
salt is a crystal formed from a sodium ion and a chlorine ion, right? So when I put them in water, that water, the negative ends of the oxygen, the electronegative end or the delta negative end of that water is attracted to the sodium, and the delta positive end, the more positive end of the water, closer to the hydrogen, is attracted to that chlorine. So it really fully ionizes in water. Ionic substances fully ionize in water. So what does that mean? That means they dissociate completely. So that crystal, or that sodium crystal, just separates and falls apart, as opposed to things that don't, like molecular substances, may only be partially soluble in water. Just to summarize the important points here, the 5 important properties. Has a high specific heat, and we call that C sub P for specific heat. And what does that mean? Remember that from chemistry? What's specific heat?
How many? What it takes to raise the 1 gram of anything 1 degree.
Yeah, it is. So there's 2 different, but specific heat is the value. So a calorie is just a quantity unit. And so it goes like this. Water has a specific heat of 4.18 joules per gram per degree Kelvin, also known as a cal. So that's just my unit. Yep. And just to compare, a metal like aluminum has a specific heat of 0.9, so pretty low. So if you think of specific heat as the resistance to change in temperature, the higher the specific heat, the more energy it takes the temperature to increase or decrease.
All metals
Move. Low, right. And so they are very conductive as a result. And they transfer heat really well. And they do it quickly. And something like ethyl alcohol, which we call ETOH, has a specific heat of around 2.44. So higher than metal, but considerably less than water. And so, the other property, great solvent. And why is that? Why is it a great solvent again? We just talked about it in the previous slide.
Because it's highly electronegative.
Because it's highly electronegative.
I missed the top part. That looks like a goofy L or a.
And it is cohesive. Sticks to itself, which is what results in surface tension. It's adhesive. Sticks to other stuff, which causes capillary action. And a biggie is its maximum density is where?
4 degrees Celsius.
There you go. Maximum density at 4 degrees C. So we really couldn't have life on Earth if we didn't have that one phenomenon of water, is that it's less dense as a solid than it is as a liquid.